And we're going to move on to a new kind of plots. So let's first take a look at like the context, right? So this time we're going to look at a data set that shows you how much a customer pays for the meal and how much he or she pays for the tip. Okay, how much they pay and how much they tip. So let's first load the data set. Again, let's actually move to Avenue to Learn. And this time the data set is tips.csv, right above this election data set. Again, let's right click, copy link. Okay, so let's do import pandas as PD. It's a new notebook, we have to do this. And then tips. Then is the name of data frame I want to use, pd.read CSV, and then the URL, right? So let's run it. Okay, so things are good. But let's also, as usual, to peek into the data set by using the head function. All right, I think I copied the wrong file. Sorry about that. Yeah, I actually accidentally copied the other file. So let's do it again. All right, this is the data file I wanted to use. Right? So every row is corresponding to one bill, right? In the bill, we include information like the total bill amount. That's the total price paid by the customer as the first column, right? And then how many dollars did the customer pay? Should not pay, tip the waiter or waitress, right? And the gender of the customer who paid the bill. Are there any smokers in this group of customers that came together with who paid the bill, right? And then the day on which the bill was paid. Also, the time column is going to be important later on. That shows you when the bill actually took place, right? It's basically, you go to a restaurant, it's either lunch or dinner. So this column includes two possible values, dinner or lunch, okay? And size is the group size of the customers, right? So usually you can go there alone or you can go with your friends, family. So this last column size tells you about how many customers in total are sharing the table. All right, so that's basically what's going on in this data set. And then this time we're going to focus on the first two columns. Right? So total bill and tip. Right? As you can imagine, there may be a relationship between total bill and tip. Usually, the rule of thumb may be 15%, 20% as the tip. So we want to see if there's any correlation between those two columns. Right? However, this time, unlike the previous examples, we're not going to completely throw away the remaining information. As we can see, even though we mostly focus on the first two columns, total bill and tip, to generate a plot, still the remaining information will play a role if we use a certain kind of plot. Right? So how do we visualize it? So which chart do you think we want to use to visualize the relationship between total bill and the tip amount? Well, if you want, you can use a line graph again, right? But in this data set, there turns out to be a lot of points you want to include in the chart. And it's going to be getting very messy if you use a line chart. So this time, actually, we're going to use the scatter plot. Okay? We can use the pyplot function, the matplotlib pyplot function. Again, it's very easy. For line graph, you use plt.plot. You can just use plt.scatter, and then basically, without much additional work, right, you can show the scatter plot. But this time, I think it's maybe a good chance for me to introduce this Seaborn library, which is a very popular library for visualization. Well, Seaborn is actually also matplotlib because it's the developer used matplotlib to build the Seaborn library. And the purpose is that we can make things easy in terms of coding. As we can see, there are many interesting things we can include in the plot in an effortless way, right? Even though we do lose some ability or degree of customization. Okay? So let's get started by doing this library. So we need to import Seaborn. I usually would give it as a shorter acronym. So for Seaborn, for some reason they call it SNS, right? So I don't know why they call it SNS, but it's called SNS. So in the meantime, whenever you're using Seaborn, it's a good idea to also import matplotlib.pyplot. Because Seaborn is based on the matplotlib library, so the same stuff we used from matplotlib can be used here again to customize your Seaborn plots, as we'll see in a few moments. Again, as PLT. Okay, so if you get an error, it probably means that you need to install Seaborn, but I believe Seaborn is automatically included in your Anaconda distribution, right? So now we have imported library to create the scatter plot. It's quite easy, but there's one nice feature about Seaborn. You can directly focus on a data frame. You have a data frame, and I focus on this data frame to create a plot. Right? So one feature is that the first input argument of this command, the Seaborn.scatterplot, is that the first thing we need to do is to specify the data frame. Right? So now let's do it. The data frame we want to use is actually tips, right? The one we just loaded. And then there's a bunch of things we can do. Let's just find them out in a few moments. Okay, so let's do sns.scatterplot. And the first thing to do is to do the data, specify the data. Now data is tips, right? Because we just loaded this tips data frame, we want to use it. Now, after you specify the tips data frame, the plot will only focus on the data frame to look at its columns, right? Scatterplot is like a line graph. You need to have the x-axis and y-axis, and here we're focusing on the total bills versus the tips column, right? So we're going to do x equal to quotes total underscore bill. That's one column from a data frame, okay? You just provide the name of the column. And y equal to tip, okay? So then we can already generate a plot. As we can see, same thing, maybe it's a good idea to do plt.show just to get rid of some of the extra display. Right, so then that's a scatter plot, right? So one thing, as we can already see is that we don't even need to include the labels. It's automatically based on the column names, right? So things are a bit more automated than what we did in matplotlib, where we always need to specify what label we need to use, right? So that's the scatter plot, right? So then we can do something interesting. So remember, in the data frame, each row can be a record from a lunch or from a dinner, right? So in other words, we can at least divide the data points into two groups, right? Lunch and dinner. Some points are for lunch, some points are for dinner. And in the Seaborn library, there's a very easy way to do that. We're going to customize the color of the points based on their type, right? Lunch or dinner. So this argument is called hue, not color, but hue. And then hue is equal to time, right? So remember, in the data frame, we just look at, there's a column time, and value in that column can be either dinner or lunch, right? That's that's telling you, when the bill was paid. Is it paid for lunch or dinner? So if you do hue equal to time, automatically it will use different colors for different values of time. Right? For lunch, it will use one color. For dinner, it will use a different color. Okay, so let's just run this command to see how things will be changing. Again, you don't have much say in terms of color, which works out, right? Because all we want to do is to have two different colors. Right? And if you want to customize the colors, there are some particular themes you can use to change the color, default colors for showing different types of points, right? But then we did lose some customization here. We don't change the color, we only specify that use different colors for different types of the meal, right? So now it also includes legend. So the blue points are the dinner points, and the orange points are the lunch points. Right? So then now we can visualize the points according to their types. Right? In addition to the relationship between dinner and in addition to the relationship between total bill amount or total tip, right? So that's something we can do, right? So another thing we can do is that maybe we can look at the group size of the customers. Right? Remember, there's a column called size that shows how many customers are sharing this meal on the bill, right? So there's a column called size. I'm going to do size equal to size. Well, the first size is the name of the keyword argument. So basically, if you include this keyword argument size, it will show different points in different sizes according to a certain attribute, right? And then the second size between the quotation marks is the column name, right? Ideally we can rename that into group size, right? But here, because the column is just the size, so we leave it like this. Size equal to quotes size, meaning that I will display the different points in different sizes according to how many people actually were having this meal, right? So then, let's see what happens. Now we can see, indeed, the sizes are different, right? For example, this point here is very small, and some points here and there are bigger, right? Right now it may not be very obvious, because the smallest point and biggest point, maybe the size difference is not significant enough for me to visualize these things very quickly, right? So one thing we can do is that we can do sizes. So this time it's a plural form. Sizes equal to a tuple of two numbers. Let's say from 10 to 300. Okay? What does it mean? So it means that I want to use 10 as the size for the smallest group. 300 for the size of the biggest group. Right? So this basically allows you to control how much difference in sizes you want to display for the different group sizes in the data set. Okay? What is 10, what is 300? Well, that's the part we don't know before we see it, right? So you can first use some random or arbitrary numbers here, and then try to visualize it, right? If you're not happy, just to do some fine-tuning to change it to maybe 10 to 500 or 10 to 200, right? Depends on whichever makes you happy about the final display result. All right, so then we can see that not only it included the sizes, showed the points in different sizes, right? And the smallest size and largest size, they represent the group size of the customers having the meal, right? And it also creates some legend to help you understand the different sizes, right? For example, the smallest point here is 1, so you can look into this chart to find those tiny points here and there have similar size as this one here. So we know that, for example, this point to the left, that's very small, similar to the smallest legend size, right? So that's, I mean that the customer is dining by him or herself, right? And then this point here, it looks like it's very close to the size of 5, right, according to the legend, right? So that's how you can tell the group size based on the size of the points and the legend, right? So again, we can see that things are more automated, right? We didn't spend effort to tell the chart to create the legend for size and the time, but it just did this for us. So this may be saving you some time for, adding extra elements to your plots. In the meantime, you may be losing some customization, right? Let's do something. Let's say it doesn't have a title, right? So let's do plt.title. So even though it's actually Seaborn instead of plt, matplotlib, but still they are the same thing essentially, right? So you can use plt commands to control elements in the chart. Let's say the title is tips versus bill, and then that will give you the title. And then sometimes you may not be happy with the labels on the axes because that's just directly based on the column name. Sometimes that's not something you want to have, right? So let's change the X label to total bill without the underscore. So the X label is changed, right? So as we can see, knowing matplotlib is very helpful, even though you really want to use a more efficient tool such as Seaborn, because that allows you to do some further customization based on the automated results. All right, questions? So, well, there are. Then one thing we didn't try, so let's try that again. So I used the hue equal to time to show the different types, lunch or dinner, right? So there's one more thing we can do. Let me remove this hue equal to time. Instead, let's do style equal to time. So this time, I'm not going to use different colors for different types of the meal, right? Instead, I'm using different shapes. Again, you don't really get to choose the shape, but then here are circles and crosses, right? So according to the legend, dinner is circle, crosses for lunch, right? So that's just another thing we can do to separate those scattered plots based on their types, okay? And some explanations here, basically we have already done them. And then as I explained, we can use pyplot to add title and axis labels, okay? Now, sometimes we want to visualize the trend, right? So if we go back to the plot, well, we see that if you only want to focus on the relationship between tip and bill, well, obviously things are pretty arbitrary, but there's a pattern, which is that in general, the more you pay for the bill, then the more you tip, which is intuitive, right? But then sometimes we may want to include a trend line to help us better understand the trend, right? So this is going to be, actually, let me quickly go back. Let me copy this scatterplot command. Let me copy the whole thing and paste it. But this time, we're going to remove all those customizations, like, showing the different types based on size or style and those kind of things, right? But then I cannot use scatterplot if I want to visualize the trend according to a line. Instead, I'm going to do something called regplot. Okay, so let's see the result. If we replace scatterplot with regplot, reg for regression, it shows you a regression line, right? And then that's when we can have a trend line, right? So it's trending upwards, then we can say that it's showing you that in general, the larger the bill, the more the tip, right? There's something actually not displayed nicely here, but on your own computer, if you are following along with the Jupyter Notebook, you will find there's a shaded area around this line. That's the confidence interval, right? So by default, it's the 95% confidence interval. It means that not only you have the trend line, but with 95% possibility, probability, the trend will look like this line. Right? So basically, that's a regression line. The relationship is demonstrated by this line as a trend, but this line may not be 100% accurate as the trend. Right? There's some room of in terms of the confidence interval. Right? Maybe the trend is deviating. Right? So there's one more thing we can do. Well, it's actually a line, right? But sometimes trends are not always linear. Maybe we can do some regression that give us some curve to show the trend, right? To do that, we can do order equal to a certain number, right? Order equal to 2, it means that we're not looking for a line. Instead, we're looking for a quadratic curve for us to visualize the trend. So let's take a quick look at see what happens, right? And nothing changes in this data set, because in this data set, well, things are that maybe the straight line linear regression is already good enough for capturing the trend, so it doesn't change too much if I specify order equal to 2. But if you do order equal to 3, things will be a bit different. Now you make the regression line more flexible. It can be a more flexible curve, right? Now you do see a curvature. Right? So if that's what you want, I mean, it's not always a good idea to use a higher order because it becomes more flexible. But as we'll explain later on, this also tend to cause some overfitting, right? It tries its best to make it flexible to capture the small trends in the middle, but that may not be true. Okay, so maybe overfitting. Maybe you don't have enough data points. It exaggerated what's happening in your data set and doesn't generalize to the general cases. Right? But anyways, if you want to have a curve, which is particularly useful if you see the trend is clearly nonlinear, then specify an order number that will get you the curve to capture the trend. Yes, please.
What did you say the default confidence level was? 90%?
95%. I believe it's 95%. But you can change it. So let me. I cannot really display because of the color, the way that the screen here display the color. But we can do CI confidence interval equal to, let's say, 70%. Right. So as in linear regression or confidence interval from statistics, if you run this command on your computer, you will see that the shaded area becomes narrower. Right. The confidence level becomes lower, and then you become less confident. So you want to sort of stick to the line a bit more closely, right? So that's how we can control things, right? So there's not a lot of customization in terms of this reg plot. It's a scatter plot with a trend line or trend curve, right? But we lose the ability to sort of define the shapes and colors based on information from other attributes of a data set. But if you want to use a trend line or trend curve, that's going to be something helpful. Okay. Yeah. So I included some comments. Some notes for the plots. That's basically the same information I just provided you. Right? So if you have time, it's recommended that you review all those notes in the Jupyter notebook as well as those in the slide. So let's just move on to the next visualization chart. And so this time, actually, let's go back to Avenue to Learn. So we have data sets for the counts of Olympic medals won by different countries, right? So let's first look at the 2016 games. Yeah, I know that the 2024 game was not long ago, but I didn't get to update my teaching materials. So let's for now, let's work on the 2016 games. So let's copy the GitHub link, and then we were gonna load that data set into as a data frame, right? So again, this time we're gonna do import pandas as PD. And then we're going to say metals 2016 equal to pd.read CSV, then the remote URL. And then we can have a quick look at the structure of the data table. So it's going to be metals 2016.head. Okay, actually, let's display the whole thing because it's a short data frame. Okay. So as we can see, it's a simple data table, right? 10 rows in total. The year 2016 is the same for every row, and the column NOC is the country codes. Right? NOC is the National Olympic Committee, so that's the name of the National Olympic committees for the different countries. The same thing as the country codes. And the medal counts, including gold, bronze, and the silver. Those are the top 10 countries won the most medals in 2016. So what we want to do is to visualize, create a chart to visualize and compare the medal counts for those countries. So which chart do you think we need to use? What is the best way to do? Yes? Bar chart, right? It's similar to histogram, but then we will do the countries listed on the x-axis, and then let bars rise from the country code, and then we can know that the highest bar is corresponding to the country with more medals. All right, so let's do the bar chart. So the first thing we do is actually maybe pay attention to this command, right? plt.bar. Again, this time we moved back from Seaborn to Matplotlib. If you want, you can also use Seaborn. We don't have time to cover everything, but basically all those packages are quite versatile. But anyways, plt.bar will help you plot the bar chart. Right? It has two input arguments. Indexes is the list of indexes. Actually, it's the list of categories. Right? And then value is the counts in this case. It can be a different attribute, like if you are creating a chart for GDP per capita, then the values should be the GDP per capita values. But now in this example, we are counting the medals for different countries. Now, before we dive in, let's look at a different, simpler example. Okay, let's say we just performed a survey for the popular programming languages, like 20 people, 10 prefer C++. 15 prefer Python, and 5 prefers Java. And then let's quickly just create a very simple bar chart. Right? Import matplotlib dot pyplot as plt. Okay, and then we can do plt dot bar. Then we need to provide the indexes, right, or the categories. So we have C++, in this example, Python, Java. So that's the categories I want to use, right? And then the second one is actually going to be the list of numbers, right? 5 people prefer C++, maybe 10 people according to my example. 15 prefer Python, right? And finally, 5 prefer Java, and then that's how we can. Did I do a? Oh yeah. Pyplot. Sorry about that. Yeah, thank you. So then basically that's a simple bar chart, right? So indicating the numerical attributes for several categories. Okay, so then that's how we can create a simple chart. But now let's move on to the data frame. Right? So we included the medal count data frame, and then there are 10 countries in the data frame. So what we can do is plt.bar, and then we want to first include the indexes, or the codes for the country codes, right? So then the data frame is medals _ 2016, and then we're going to take the column called NOC. That's the country name codes, right? And then The second one is medals 2016. The column will be medal. And that's the medal counts. How many medals do they win at the 2016 games? Okay. So let's just that's it. Let's just display it first, right? And then what we have done before, we're gonna incrementally add elements to the chart. Okay. So one thing we can do is that maybe color. Let's do color equal to yellow. Maybe orange. The yellow is a bit too bright, I feel. Okay, so then if you want, you can do some edge color equal to black. So you will have black, outlines for the bars, which is not essential, right? So then we can do plt.title. Let's say 2016 Olympics. Okay, so we can do plt dot y label because we want to show the y label as the medal counts, right? So the height of the bars represent the medal counts. So now we have a y label, right? So then if you want, you can do plt dot grid. Let's say axis equal to y. Then you will have grid lines according to the marks on the y-axis. Right? That helps you better understand or better visualize how tall is each bar. Right? So sometimes the simple thing can be very helpful. I mean, you can also specify a line style argument, line style equal to, let's say, column. So that becomes dotted line. Not very obvious, but maybe make it dashed line. Not very obvious on the big screen, but this way is better, right? So that's how we can quickly create, the bar chart, right? So, and so I think it's pretty complete, right? So then the next thing we want to do, maybe we can do one thing, because if you think you want to have narrower bars, then you can use the width parameter. And let's say width equal to, by default, the width is 1, right? So the unit measure on the x-axis, you can make it 0. Let's say 0.6, so that they become a bit narrower, right? So that's some customizations we can do, not too different from before, but let's do something that is interesting. So let's copy all those lines of codes and paste it into a new cell, right? So now instead of bar, I'm going to do bar H. So what do you think it will show us? Instead of width, let's do height. And instead of axis equal to y, let's do axis equal to x. So let's change it. And you can see that it's again a bar chart, right? But, well, it becomes horizontal bars, right? I mean, not too different, but depends on your purpose. So I had to change a few parameters after I decided to use the horizontal bar. One thing is that instead of width, I need to specify the height. Right? Now it's not width, it's like the height of each bar because it's going horizontally. And axis equal to y, I change it to x. You can do y, but you can see that it shows you y, the grid line for the y-axis, which may not be useful for a horizontal chart, right? Doing x, that help you better visualize how long is each bar, right? According to the marks on the x label. All right, so that's the horizontal bar. Questions? All right, so then we're going to talk about multi-series bars. So currently, we only focused on the 2016 game. What if I look at multiple years? I want to create bar charts for both years, but throw them into the same chart, right? So let's load the data set for 2012, And then again, Avenue to Learn, GitHub link for the 2012 data set. Nothing too different, but metals underscore 2012, a new data frame, equal to pd.read CSV, and then the link. And we can look at metals 2012.head. Maybe not, because there's only 10 lines just to show the whole thing, right? One thing important to pay attention to is that here the order of the countries appearing in all those rows are exactly the same as the previous data file. And that's, of course, I had to do some adjustment. But if they are, in case the order is messy, you can just use the sort value function to have it sorted, right? So with numbers, you can do ascending, descending. For the middle column NOC string values, you can still do ascending, descending, but then it will be alphabetical ascending or descending. Okay, so basically the same values, but then we want to do the same thing. But one thing different is that I want to do things in the same chart, right? So what we want to do is that, let me copy and paste. Sorry. Let me quickly go back. Let's do the vertical chart. Again, copy everything here. Okay, and paste. Now, I will change all the 2016 to 2012. Okay, and then the width, I want to make it a bit narrower. Let's say 0.4, and you will see why. And then title, maybe change it Olympics medal counts. Grid line is okay, right? So this will plot you the 12 games. Right? I mean, nothing too different from before, but maybe change the color, right? Let's use blue, for example. And then I'm going to use a alpha parameter, alpha equal to 0.4 to make it transparent, right? So it's a blue, but a bit transparent. Then let's also plot. I just copied and pasted the first line of the code, right? But then after I pasted, let me change 2012 back to 2016. And the color, let's use maybe orange. That will plot things in the same chart, right? So let's first run it and see what actually improvements can we imagine. Sorry. Let me quickly see what's happening. Oh, another typo. Sorry about that. Orange. Should be correct? No? How do you spell orange? Ah, yeah. Sorry about that. Well, things are not so nice, right? Because, I mean, it may not be very obvious, but if you look at the charts, what's happening here is that the overlap, right, which is no surprise because they all rise from the bottom of the x-axis, right? So they overlap. So how do we make it a bit nicer? Well, I don't want to move them. Oh, yes, please.
Are you able to offset it?
Offset it. Maybe move the bar of the 2016 medals to the right? So that's the one thing we're going to do. But there's another thing which may also be helpful. Maybe we can do a stacked bar chart, right? We let one set of bars sitting on top of the other set, right? So let's let the 2016 data sit on top of the 2012 data, right? So then what we can do is very simple. Bottom, so in the 2016 command, we can specify the bottom value. Bottom equal to medals underscore 2012 and select the medal column, right? So then in this way, we specify a bottom for the 2016 games. By default, it always rises from x-axis. Now, if I specify the bottom as the 2012 medal counts, right? So for example, for this one, I think it's Australia, right? For the 2016, it doesn't go directly from the bottom. Instead, it will go from the top of the 2012 medal count bar. And same thing for the remaining bars, right? So let's try to do it. If you do a side-to-side comparison, you'll find that the total height is going to be taller because we're stacking the bars together. And one benefit of doing this is that it allows us to visualize something, some useful thing, right? Because not only I can visualize the medal count comparison between the different years, the different countries, right? But we can also sort of, if you consider the total height of the two bars for each country, it's actually, we're also in the same time visualizing the total medal across the 2 years, across different countries, right? So that's something useful to be done. Okay, so one thing we didn't do for the line charts, but something we should have done, is the legend. For seaboard, the legend was created directly for us automatically, but for matplotlib, we have to add it manually, right? So basically, we have yellow and blue looking at the commands, and we know which is which, but actually we don't know if we supply this to the end user who only have the charts, not the codes, right? So in order to do the legends, I have to set labels. I'm going to label the 2012 chart. Let's say just label is very simple, just do label equal to quotes 2012, right? And then for the 2016 plotting command, just to do same thing, label equal to 2016. And then before you do plt.show, which I didn't do, but you can, it's usually a good practice, right? And then you can also do plt.legend, and things are done, right? So just to recap quickly, what we have done is that we put a label to those two set of bar charts, right? And then finally, if you already set the label, you call the command plt.legend, and it will show you the legend. Now people know that the blue bars are for 2012, and the yellow bars are for 2016, right? Questions? Okay, final bit. So this time we're going to do the offsetting, side-to-side bars, right? So this time, I think we should be able to finish it. So let me pace up a little bit. So this time, let's do NumPy. As you will see how we're going to use NumPy here. A very simple operation using NumPy. All I want to do is to do something called, define a variable, positions, equal to np.range 10, right? And you can see the positions just from 0 to 9, right? 10 numbers. So when I'm doing the multi-serial bars and I want to include some offsets, let's first define the positions of the bars for the first set of bars, like 20 to 12 games, okay? And then let's plot the 2012 games. So that's the command, right? So I just copy it and paste it. But this time I'm not going to do the NOC column, right? Because if we do the NOC column, it will have overlapping, as we have seen before, right? Instead, I'm going to do positions. Okay, so then, as we can see, now the bars are from position 0, 1, 2, 3, 4, and so on and so forth, right? But we know that the first one is Australia, second one is the second row in the data set, right? It's just that I changed the label from the country code to the positions. Later on, we're going to change it back, right? Now, let's copy this whole line and then paste it. Then again, change 2012 to 2016. Change the color to yellow. As we can see, this is overlapping, not surprising, right? Because I use the same positions. But we can do In the 2016 plot, what we can do is that I can do position plus a small number, 0.4. Now, what we'll do is that for the first set of bars, it goes from 0, 1, 2, 3, so on and so forth. The second bar, if I offset it by 0.4, it will be 0.4, and then 1 plus 0.4, 1.4, and 2.4, and so on and so forth, right? That's how I can offset things slightly. Now we have side-to-side bars, okay? One thing not looking so good, because we still have, the numbers on the horizontal axis, right? Now let's add them back. So this one way is something we can do using plt.xticks, right? Remember, xticks allows us to set labels for the tick marks, right? So we have the positions as the list of positions I want to label on the x-axis, right? But then the second list is going to be medals 2012, and then this time I'm going to add back the NLC column, right? Because those 10 positions are corresponding to the country codes in the NLC column of either data set, right? They're the same. So let's do plt.show to see everything shows up correctly, but it doesn't let me see. Xticks, sorry. Right, so now I have replaced the numbers on the x-axis because it was positions from 0 to 9, right? Now I replace it by the corresponding country codes. So then things are much nicer for the side-to-side bar chart.